Okay, so a lot of you have been asking me questions about uh, this last task, this last challenge that I gave you guys, which is to make your cart end or land as close to exactly 12 feet as possible. So here you have a cart, and there's a mouse trap on it, and then the thing, and it goes like that or whatever. Uh, and then here's where you start, here's where you finish. The distance between these two is 12 feet, and I want you to make that cart end right on the money. Okay, if the cart ends right on the money, you did great. If the cart can end right on the money in 3 seconds or less, even better, which is very hard. I don't expect too many people to get it, um, but that's okay, because even if you don't, you still get an A. It's not a big deal. So I discussed 3 different ways to do it. The first way is to make a device that runs out of power. So most of you guys made a device that can go 15 feet or 20 feet. Um, and a lot of you, or a few of you, made devices that just barely ended up at 12 feet. So if your device just barely ends up at 12 feet, you're done. You don't have to do anything unless you want to try to fit it in that 3 second window. Okay, so that's the first way. The second way is to add some kind of a break to your mousetrap. So let's take your mousetrap. Here it is, laying on it's on a table or something. There's a spring right there, and there's a bar that goes like this. And when you pull that bar back, uh, it stores energy in the spring, and when you let it go, it snaps forward, and depending on how well you built your car, transfers the energy to your car, and it makes your car go. As most of you found, or if you watch my other video, if you just leave the bar the way it is and don't modify it at all, it's gonna be very difficult to transfer energy from the spring to your car. That's because there's a lot of force and there's a lot of power that's coming out of that spring, and it's happening very quick, and that generally is not going to give your car enough time to actually use that energy. Your tires are going to spin out, or your string is going to snap or spin out, whatever. And so you've noticed that the longer you make this arm, this lever, the longer the distance it travels, which means that it's not supplying as much force. As we talked about in class, the impulse is equal to force times time. So the impulse in object experience is equal to force times time, or the impact in object experience is force times time. And so the longer time it takes for this whole thing to happen, the longer time that takes, the less force, which is okay, because it doesn't take a lot of force to move your device. Your device doesn't need a lot of force. So especially when you're going for distance, you want this lever to be as long as possible so that it just barely makes your car move. So you want the minimum amount of force that will move your cart, which will give you the maximum distance here, which will give you the most efficient energy transfer. When you're doing something like making a cart that's going to go fast, you want a shorter lever so that you can get more of that power. Remember, the less time it takes, the more power you're giving your device. And so to make something go fast, you don't want the distance, you want the power. To make a device that stops, though, you are going to want to put some brakes on it. So if you can make a fast device with brakes, then it's going to be able to go the 12 feet quickly, but then stop where you want it to stop. So let's redraw our mousetrap, the lever arm here, and let's say you extend it just a little so that you get speed. Well, what's going to happen when you pull this lever back? So you're going to pull it back, and the lever's going to be, say, here. And when you let it go, it's going to go back to its original position. Well, what if you added some kind of thing that sticks out like that? Well, what would happen when the lever eventually snaps shut? Well, instead of this, you would have this. And imagine if you have some tires here, or some wheels there, and here's the ground. Well, now you've just put a brake onto your cart. Now, when it snaps shut, you're going to have a lot of friction right there, and that's going to cause your cart to slow down, or your car to slow down. So this was the second thing that I was talking about, is to put some brakes, something that is going to increase the friction between your car and the ground. The next way to put brakes on it, imagine here's the axle, and so you have a tire here and a tire there. And this is going to be, you're going to have your string wrapped around this, which goes to your lever, whatever. And so when you pull the lever, it pulls the string. Pulling the string spins the axle. Spinning the axle spins the wheels. Perfect. There's something called a wing nut. If you look on YouTube, most of the people who make videos on how to make a car go an exact distance have a little metal piece. Let's see if I can draw it. That looks like that. And so what happens is the tires spin, especially if you need something that stops it's called a wing nut, that stops the wing nut from spinning at the same time. So you put some kind of stopper on it. And as the tires spin, this wing nut is going to move that way. Okay, so imagine if you had a screw or something, and as you turn it, it's going to move up or down the axle. So you would have to have some kind of a screw here that the wing nut can spin on, and then as your tire spins, the wing nut gets closer, and as you get right to 12 meters, your wing nut would be pressing up against your tire, your wheel, and that would be another way to put a brake on your car. The last way, maybe the most fun, is to design your device so that it breaks. Not like car brakes, but falls apart brakes. Okay, so for example, you have your front wheels fall off. And you can do that in a similar way to what I just talked about. Say you have your wheel attached to a screw or a bolt of some sort, and as your wheel spins, say this is your front wheel, once it gets to 12 meters, the front wheel just falls off. And so if the front wheel falls off, your car's not going to go anywhere, and you're done. So when I said you had a few different ways to do it, this is what I meant. If you have questions, a lot of people have been asking questions, and I tell you, hey, just set up a meeting with me. Tell me when you're free. I'll open up a Zoom meeting. You come in and I can see your cart. I've helped a couple people like that. And you can show me on the video what your device looks like. And I can then give you the pointers that you might need to do that. All you have to do is say, hey, Mr. Halloran, I'm free at 3 o'clock today. Are you free? I'll say, ooh, 3 o'clock. Actually, no, I have something to do. What about 3:30? And you'll go, 3:30, that's a perfect time. And I'll go, perfect. I'll set it up. I'll send you the link. Boom. And then I'll get you what you need. Okay. So here's the video I promised. I hope it helps. If not, whatever. Maybe you won't even watch it. Who knows? I hope everybody's safe. I know some of you guys are sick, and some of you guys are having uh, some issues. Just know I'm praying for you guys. I wish I could see you, but we got to do what we got to do. I'll see you when I can. You guys have a good one.